Okay. Are we good now? All right. So number one. So this is the 14.6 worksheet. So grade with a pen. Don't have any pencils out. Oh, you need a pen?
Hey,
Angela, also.
thank you, sir.
Anybody else need a pen? Okay, number one. The answers are 0 degrees, 30 degrees, 180 degrees, and 330 degrees. Anybody need to see that one? Good? All right. On to number two. The answers are 45 degrees, 90 degrees, 135 degrees, and 270 degrees. So if you missed any part of it, just put a slash through the number, okay? And then I'll go back and decide how many points to take off. Okay? Number three. Nobody needs to see number two? We good? Okay. Number three, the answers are 3 pi over 4 or 7 pi over 4. You could also write them as 3/4 pi and 7/4 pi. Okay, still good? All right. Makes me nervous when y'all are really quiet. Either y'all are doing really well or you're clueless. So I hope it's the first one. What now? It says 3:30, yes. Number four, it's 0, 2 pi over 3, and 4 pi over 3.
Can we work number 4?
We can work number 4. All right? So here we go. Number 4 says tangent squared plus secant x equals 1. By the way, I was teaching this at the college level one time, and I had this whole problem with secant x, and I took the c out a couple times when I was writing it. And so the class was laughing. I had no idea why, and I looked back and I'd written sex like 4 times on the board. So anyway, so somebody tell me what you would do. Remember, you want it to equal 0.
Would you make the tangent square x into secant
Yes. Well, why would you want to do that?
to get it?
You want it to have only one trig function, okay? So we need to either change this to secants or this to tangent or everything to sine and cosine and see if that helps, okay? But what is the what am I trying to say? The identity that has tangent squared in it.
Secant squared or secant x
Plus 1
Yeah.
is tangent? Is that it?
No, tan x plus 1 equals secant x.
Is that right? Is it tangent plus 1 is secant or secant?
Tan plus
Okay. So if tangent squared x plus 1 is secant squared x. That's it? Okay. I always have trouble remembering those anyway. But so for tangent, it would be secant squared x minus 1. Right? Plus secant x minus 1 equals 0. So then you've got secant squared x plus secant x minus 2 equals 0. Now you want to factor. Well, think of secant as your variable. If secant is your variable, like say if a were secant x, this would be a squared plus a minus 2. And you could factor it really easily. You want the factors of 2 that subtract to be 1. So it would be secant x plus 2 and secant x minus 1. Right? Now when we get to the end of this one, do we have to check our answers? No. When do you have to check your answers? When what happens? Square both sides. Hold on just 1 second. All right, so yeah, if you square both sides, you have to check your answer, but we haven't done that yet. So here we have secant x plus 2 equals 0 and secant x minus 1 equals 0, right? So this says secant x equals negative 2, and this says secant x equals 1. Now, can secant be negative 2?
No.
Yes. Okay. Secant is 1 over cosine, right?
Right.
So 1 over cosine can be anything except 0. If that said cosine x equals negative 2, there'd be no, because cosine's got to be between negative 1 and positive 1. So does sine. But here, if secant of x is negative 2, that means cosine x is negative 1/2. Okay? Now, where is cosine 1/2? Think of it this way. So that's in a 30, 60, 90 triangle, right? Which is also a pi over 6, pi over 3, pi over 2 triangle, okay? Where this is 1, this is square root of 3, and this is 2. So cosine of what angle is 1/2? Pi over 3. So it means our reference angle is pi over 3, but it's negative. Where is cosine negative? In which quadrants? Second and third. So we've got pi over 3 here and pi over 3 here. So what is that angle? It would be, the whole thing is pi minus pi over 3, which is, that's 3 pi over 3 minus pi over 3, so that's 2 pi over 3. Then what would this angle be? The pi plus pi over 3. So that'd be 3 pi over 3 plus 1 pi over 3, which is 4 pi over 3. So we got those two. Then here, if secant is 1, what does that mean cosine is? 1. Now, is that in a special triangle or unit circle? Unit circle. Cosine is your x coordinate. So where is that?
0.
And it's at 0, because that's the 0.10. So you got x equals 0. And those are your 3 answers. Okay? Number 5. You still need that? Okay. And 2, I am going to post this video, so you don't have to copy down every single thing. I'm going to start posting it as soon as this class is over so that y'all know.
That's a 4 pi over 2.
last one too.
Mm-hmm.
2 pi.
No, 2 pi over 3, 4 pi over 3.
Yeah, that's
Okay. Awesome. We got one more?
One more missing. Did you get my email about when
Yes.
they come in?
Yep.
A yellow.
Now, I have a sub today, so tell Miss Plump, but I'll tell her.
Okay, but they need to fill out that pass.
Yes.
Tape it to it.
Okay.
And I
Fourth
can
Fourth period is the only period people should take it out because every other period they're going to be with me.
Well, I need
But
to
yes.
engage the teachers to say. where's
Agreed.
the homework pass?
Got it.
Where's the homework?
Okay, thanks, Molly.
Thank you. Sorry for interrupting.
No problem. Okay, so number 5. The answer is 90 degrees plus 180 n. Okay? Now, there's several other ways to write that. You could write it as, so let's see. You could write it as 90 degrees plus 360 n and 270 degrees plus 360 n. So you could write it like that or like that. Either is fine. Okay, does anybody want to see that one? Yes? Okay. So let's see. Number 5 says sine squared x cosine x equals cosine x. Okay, so first we want it to equal 0, right? Now this is one, I'm actually glad we're doing this one because we didn't do one like this. There are 2 ways you could do this now. We could make everything cosines by changing sine squared to be 1 minus cosine squared, right? Problem with that is if you do that, you get a cosine to the 3rd. And it ends up being a lot harder to solve. But what if I factored out a cosine from the beginning? What am I left with? It's okay if each factor only has one trig function. Does that make sense? Okay, so instead of making the whole thing have to have one trig function, it's okay if just each factor only has one trig function. So this factor just has cosine, this factor just has sine. Because what you're going to do is you're going to say cosine x equals 0 and sine squared x minus 1 equals 0. So you can solve both of those without having to convert anything. So when is cosine 0? Is that on unit circle or special triangle? Unit circle, and cosine is your x coordinate. So where is that 0? It would be, no, at 90 and at 270. This is 0, 1, and this is 0, negative 1. So we have x equals 90 degrees and x equals 270 degrees. Okay? Then here, we've got sine squared x equals 1, right? If you take the square root of both sides, you've got 2 things. Sine x equals 1 or sine x equals negative 1. Where does sine equal 1? Oh, at 90. Sine is your y coordinate. So x equals 90 degrees. Where is sine negative 1? At 270. So
would you have to check those?
So you don't, because you didn't square both sides. You can square root, that's fine. So your answer, since it says for all values of x, not between 0 and 360, you would do 90 plus 360 n or k and 270 plus 360 n or k. Okay? Number 6. Yes. Mm-hmm. I mean, you would, if you went to her, she knows how to do it and she's teaching it. And there are just a couple different methods, but I don't mind if you learn a different one at all. And I'm here before school every day. So if you could come early before. All right, so number 6. The answers are 30 degrees plus 360 n, 90 degrees plus 360 n, and 150 degrees plus 360 n. Anybody need to see that one? Okay. Number 7. The answers are 60 degrees plus 108. Well, I don't like when they write it this way, so hold on. I'll write it the way they wrote it, and then I'll write it the way I taught you. Okay, so you could have that, or you could have 60 degrees plus 360 n. 240 degrees plus 360 n, 120 degrees plus 360 n, or 300 degrees plus 360 n. This is what I would have written, according to what I taught y'all. But if you put this, that's fine too. Okay?
How do they get
what they're saying is, okay, so they saw that it was 60 and 240, and those are 180 degrees apart. So instead of saying you could go here and add 360 many times you want, or you could go here and add 360 as many times as you want, they said you could go here and add 180 as many times as you want, because it would either put you there or back there, or there or back there. So when you get two angles that are directly across from each other, instead of saying you have to start here and go 360, you could say, well, you have to start here and go 180 each time. So do this. Don't worry about it. Okay? Number 8. The answers are 90 degrees plus 360 to 70 degrees plus 360 45 degrees plus 360 and 315 degrees plus 360
Can you work that?
I can. So number 8 says square root of 2 cosine to the third x equals cosine squared x. So first thing is get it equal to 0. Right? Then it's already all cosine, so we're good there. And you can factor out a cosine squared x, and you're left with square root of 2 cosine x minus 1. So we have two equations, cosine squared x equals 0, or square root of 2 cosine x minus 1 equals 0. This, if you take the square root of both sides, you would have cosine x equals plus or minus, you don't have to do, 0. Okay? Here we got square root of 2 cosine x equals 1. Divide both sides by the square root of 2. And you've got cosine x equals 1 over square root of 2, but that is square root of 2 over 2. So cosine is 0. Is that the unit circle, special triangle, or use your calculator? Unit circle. Where's cosine 0? Cosine is your x coordinate, so at 90 and at 270. So you've got x equals 90. And then if it just said from 0 to 360, that's what you put. But it said for all, so you add plus 360n. And then also 270 plus 360n. Okay? Then over here, where is square root of 2? Where is cosine square root of 2 over 2? 45, but it's positive, right? So which two quadrants would it be in? 1 and 4. So this angle is just 45 degrees, right? So you got 45 plus 360n. This one would be 360 minus 45, which is 315 degrees plus 360n. And those are your 4 answers. Okay, number 9. Number 9 says cosine squared theta equals, or no, let me just say the answer first, sorry. The answer is pi over 4 plus 2 pi n and 3 pi over 4 plus 2 pi n. Or, yeah. Anybody need to see that one? Okay. So we've got plus 2 pi n, yes. So we've got number 9. Cosine squared theta equals sine squared theta. Okay? Well, the first thing we're going to do is get it equal to 0. So we got cosine squared theta minus sine squared theta equals 0, right? Yes, yes. So we need to get rid of one of the trig functions. So I would get rid of sine squared, okay? Sine squared plus cosine squared equals 1. So in place of sine squared, we can write 1 minus cosine squared. So that becomes cosine squared theta minus 1 plus cosine squared theta. Right? So that becomes 2 cosine squared theta minus 1 equals 0.
Okay.
Right? Now we can't factor, but we could solve for cosine. If you take the 1 over, that's 2 cosine squared theta equals 1. Divide both sides by 2, and we get cosine squared theta equals 1/2. So then what? Square root both sides, which means we got to check our answers. So that means cosine theta is plus or minus the square root of 1/2, which becomes square root of 2 over 2. Okay? So, where is cosine square root of 2 over 2? 45, but it is 45, it's in 2 quadrants. So we know that, well, and actually it's pi over 4 because we're doing it in radians. So theta is pi over 4, but in which 2 quadrants is cosine positive? So here it is just pi over 4. For this angle, it's 2 pi minus pi over 4. So you got 2 pi minus pi over 4, which is 8 pi over 4 minus pi over 4. So you've got theta equals 7 pi over 4 plus 2 pi n plus 2 pi n. Right? Then negative is just the other 2 quadrants, right? So pi over 4 for that one, you've got pi minus pi over 4. So that's 4 pi over 4 minus pi over 4. You get theta equals 3 pi over 4 plus 2 pi n. And then lastly, where have we not done? Here, or here. So it's pi plus pi over 4, which I'll just go ahead and tell you ends up being 5 pi over 4 plus 2 pi n. Okay? And shortcut for time, all 4 of those work. Okay? So you keep all 4 of them. You'd have to check them, but they all work.
Yeah, I thought it was just pi over 4.
Well, hold on. Let me check then. So let's see. At pi over 4, if you square cosine, you get square root of 2 over 2, so you get 1/2, right? If you square sine, you get 1/2. So 1/2 equals, it is going to work for all 4. I must have made a mistake when I said the answer. Okay? All right. So it's all the 45s. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, number 11 or 10. I've got pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, And, God, this is awful. Pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. Okay? You want to see that one?
No, I don't.
I want to say.
Well, let's just hold off on that one because we're going to use, really didn't need to do the whole class on just this worksheet. So if you want to come before school, I'll work that one with you. Or I'll try to make a video doing it if I can remember. Okay, number 11, we've got pi over 4 plus 2 pi n and 3 pi over 4 plus 2 pi n. That's it. Anybody want to see that one? That one's faster, if you want to see it. Okay, last one. We've got cosine, I'm sorry, I was writing the problem. It is 0 plus 2 pi n and pi plus 2 pi n. Anybody want to see that one? Are we good? Okay. Turn those in with just slashes through anything that wasn't 100% correct, and I will decide on points. Okay? And then your classwork / homework is the practice test in the back of the book. So it is page 'I don't know if I can find it. Here we go. It's page 925, the whole page. Chapter 14 test.
We never turn in the 914 for.
Okay, you can turn it in then. Yeah, let me stop this recording and I'll do that. And that way, if somebody doesn't want to see it, they can just,
Wait, what's the date?
sorry, hold on one second.
What's the date? Oh, it's